Good morning, children. The next topic in your chapter, that is chapter 2, is rest and motion. So, you already know these things that whenever a body is not changing its position with respect to its surroundings, then it is said to be at rest. Okay, and when a body is changing its position with respect to its surroundings, then we say that it is in motion. So every time we need to mention that with respect to the surroundings. This is important to mention because we this motion and the position of rest both are relative. Okay. For example, when you are in a train, then you find that the person next to you is stationary, he is at rest sitting next to you, but a person who is outside the train will see that he is also moving along with the train, right? So this thing, rest or being in motion, is relative. So you need to mention that the thing which is not changing its position with respect to its surroundings, that is called said to be at rest, and the body or anything that is changing its position with respect to its surroundings, that will be known as or that will said to be in motion, right? So, and then we have to talk here about one dimensional motion. So when a body is moving along a straight line path, then we say that it is in one dimension motion. Okay, when it is moving in a straight line, okay, not changing the direction, it is moving in a straight line, then we say that the body is in one dimensional motion, right? Another thing, how do we represent one dimensional motion? What do we do? See, we any line that will be parallel to the x-axis, that can be uh, said to be that it represents the one dimensional motion. Okay, the path of one dimensional motion can be represented by a straight line parallel to the x-axis if x-axis is taken in the direction of motion. So x-axis should represent the direction of the motion, right? So you can see here figure 2.1, they are showing you the representation of one dimensional motion. So one horizontal line is drawn, and see, to the very left of the this line, they are showing the instant t is equal to 0, the initial moment from where we are starting to measure, right? So there x is equal to 0, no the body has not moved yet, and then at t is equal to 1 second, it has moved 5 meter, then t is equal to 2 seconds, it has moved 20 meters, and this distance 5 meter 20 meter is measured from x is equal to 0. The body has started from there and it is moving like this. This is shown in the represented on this line. Then distance and displacement. Distance is the total length of path through which a body moves. Okay, what does this mean? See figure 2.2. This figure shows the motion of a body from A to B, right? But along which path? Along the path that is shown with the help of this arrow. Okay, this arrow is showing you the path. See, this way, this arrow is showing you the path of the black line that shows you the or basically the curve that is showing you the path that was taken by the body to move from A to B. So when you consider the path, then you say that you are measuring the, or you are talking about the distance. But the line AB, can you see the line AB, the straight line, that will show us the displacement. That is the distance of or you can say that is the you can say the shift of the body from its initial position. Okay, or you can say that the shortest distance between the initial and final position, that is known as the displacement. So I hope you can understand this. There are the basic difference between distance and displacement is that distance depends on the path taken, but displacement would not depend on the path taken, right? So this you can understand. Suppose you are going from your home to your school, right? So there can be two ways: either you go straight to the school, or you first go to your friend's house and then you go to the school. Then displacement is the distance between your house and the school, but distance will be the distance from your house to the friend's house and then friend's house to school. This whole thing, when summed together, that will give you the total distance traveled. So distance is a scalar quantity. It does not depend on the direction. So it is a scalar quantity. The SI unit of distance will be meter. You can see here the SI unit is meter, and the CGS unit, it is centimeter. Then come to displacement. Displacement, as I just discussed, it is the shortest distance from the initial position to the final position. Okay, so that shortest distance gives us the magnitude of displacement, and direction will be from initial position to the final position, from wherever the body has started to move to the final one. That will be the direction of that body, direction of the displacement. So you can again see here in figure 2.2, the blue dotted line is also having an arrow. Okay, so this arrow shows you the direction of the displacement, right? That the body has started from A and it goes to B. So this shows you the displacement. But the another curve from A to B, that shows you the distance. From the blue line is showing you the displacement, and the black curve shows you the distance. Now, because displacement is having a direction, it is a vector quantity, and it is, I told you in the previous video, that vector quantities are represented by an arrow on the top. See here. So here displacement is denoted by a capital S and an arrow on the top. Then again it is measuring the distance, basically the length, the shortest distance it is. So its SI unit will also be meter and CGS unit will be centimeter. So units of both distance and displacement are same, but the distance is a scalar quantity, displacement is a vector quantity. Now there's one thing you can see in figure. Suppose okay, let us discuss point wise. So distinction between distance and displacement. The magnitude of displacement is either equal to or less than the distance. Displacement can be either equal to or less than the distance. Okay, it won't be more than the distance, right? Then the distance is the length of path traveled by the body, so it is always positive. Distance will always be positive, but displacement is the shortest length in direction from initial to final position. Okay, displacement shows the direction from initial to final position. So if the body is moving in the opposite direction, then we can say that it is negative. So displacement can be positive or negative both. Distance can only be positive. Displacement can be zero. Suppose you start from your home and you come back to your home again, then the displacement from your home is zero. You came back there. But distance will be the whole path you have traveled. Maybe you went to the market, you went to the school, and then you went somewhere else, and then you came back to your house again. Then all the path you took, that will sum up to give the distance, right? So see here, the distinction between distance and displacement is given. That is important for you. You need to learn and understand these things. Then let us come to speed and velocity. So speed of a body is the rate of change of distance. rate of change of distance. You have to remember here that speed is the rate of change of distance. So distance upon time, whenever you say that rate of a body, rate of a physical quantity with time, okay, rate can be with some other thing also, but here we are talking about rate of change of distance with time. So with time, that means we need to divide it with by time. So speed is equal to distance upon time, and because it depends on distance, therefore as distance is scalar quantity, speed is also a scalar quantity. Then in order to get the unit of speed, see, we have discussed the derived units in previous chapter. So you have to keep that in mind. To get the unit of speed, what do we need to do? Unit of distance divided by unit of time. Unit of distance is SI unit if we talk. Unit of distance is meter and unit of time is second. So the SI unit of speed is meter per second, and the CGS unit will be centimeter per second. Okay. Then there's one thing, that is uniform speed. So if a body is moving equal distance in equal time intervals, then we say it is moving with a uniform speed. Okay. But if the body is changing its speed, maybe it is traveling a particular distance in some interval of time, and in another interval of time it is traveling some another distance, okay, then we say that it is having a non-uniform or variable speed, something that is changing, that is variable. Okay. Then there's another thing, that is instantaneous speed. Instantaneous is the term when we talk about anything at that particular instant, okay, at that particular moment. So instantaneous speed, the speed at a particular moment, but here a moment we cannot calculate, no. So we take a very small time interval and take the distance traveled in that small time interval divided by the time interval, and we'll get the instantaneous speed. So instantaneous speed is the distance traveled in a short interval upon that time interval. Then average speed. Average speed will be the ratio of total distance traveled divided by total time taken. Okay. So next thing is velocity. Velocity is the distance traveled, or you can say the rate of change of velocity is the rate of change of displacement, or you can say distance traveled per second in a particular direction. Okay. So here the direction is involved, therefore velocity becomes a vector quantity. See figure 2.5, a body is taking a circular path. Okay. So in a circular path, a body has a constant speed, but direction is changing at every moment. Can you see at point A? See, in a circular path, the tangent shows you the direction of speed. Okay, so at A, can you see the tangent drawn with the blue line, blue arrow? That is showing you the direction at that particular moment. At point B, the direction has changed, okay, to the left side. Then at point C, it comes downwards, and then at D, it is to the right side. So the direction is changing, therefore velocity is changing, but speed remains constant. Then again, instantaneous velocity, it is similar to the instantaneous speed. Instantaneous velocity will be the velocity divided by a small time interval. Okay, change in displacement in a small time interval, and then it is divided by the small time interval, that gives you the velocity. So instantaneous velocity is the velocity in a at a particular instant. You can see here it is measured by finding the ratio of the distance traveled in a sufficiently small time to the time interval. Then average velocity, If the velocity of a body moving in a particular direction changes with time, the ratio of displacement to the time taken in the entire journey is called its average velocity. Now see, there is nothing such as total displacement. At when we are talking about 2 points, or say we are talking about a particular time interval, then whatever the final uh, uh, point is, final position, and the initial position, from both of these we'll get the displacement, right? So what that only is called displacement. So whatever displacement has taken place in that time interval, so that displacement divided by the total time taken, right? So distinction between speed and velocity, this also you need to remember. See, this is given over here. So first, you can write the definition. The distance traveled per second is called speed. The distance traveled per second by a body in a particular direction is called velocity. So speed is a second point. Speed is a scalar quantity. Velocity is a vector quantity. This much is sufficient. You need not write this. The next sentence: the speed does not tell us the direction of motion. Simply scalar quantity. That means we are not talking about the direction here. Then speed is always positive because direction is always positive, and because displacement can be positive or negative, therefore velocity can also be positive or negative. And after one round in a circular path, the average speed is not zero. Average speed will be the total distance traveled upon the time taken. So it can't be zero because distance can't be zero. But velocity, because when a body starts from a particular point and comes back to the same point, the initial point, that is, you can say that in a circular path, the displacement will be zero, and therefore the average velocity is zero. Okay, so you just go through the examples once, and then the next topic is acceleration and retardation. This will be taking in another video.